Okay, chapter 4, three-dimensional structure of proteins. Now, a few principles we need to keep in mind here when we are talking about the three-dimensional structure of proteins, okay? Proteins are stabilized, okay? It's not always going to be covalent bonds. The majority of them are going to be those non-covalent interactions we've talked about before. Hydrogen bonds, ionic bonds, hydrophobic interactions. So keep in mind that those are going on, and these are going to affect the phi and psi angles. Remember the phi and psi angles we talked about in class, where you have the alpha carbon and the planes of the carboxyl and the amino group and the neighboring amino acids, how they can rotate around the alpha carbon, which is acting as a chiral center. The different sections of the polypeptide are going to take on different structures. You know, whether it's an alpha helix, beta sheet, and again, it goes back to those phi and psi angles. How are they around that alpha carbon? Because remember, when it comes off the alpha carbon, that angle set, they can just rotate around. What is their direction of rotation? The tertiary structure is going to be nothing more than that sequence of alpha helices, beta strands, or do they come together to form beta sheets, beta turns, and that sequence is going to be held together in more of a three-dimensional space, again, through different non-covalent bonds, hydrogen bonds, ionic interactions, and whatnot. It all goes back to the amino acid sequence. There's an unknown number of ways things can fold, you know, with the amino acid sequences. But the amino acid sequences, more often than not, are going to fold to the lowest entropy, as we're going to see in this chapter. Going to fold in such a way that takes less energy to make it happen, takes less energy, if any, to maintain it. When it comes to proteins, the individual types of proteins are going to have a specific three-dimensional shape, globular, filamentous, and so on. Okay, globular protein's always going to be a globular protein. Globular protein's not going to suddenly be filamentous. Filamentous is not going to fold around and become a globular. And we're going to look at what is referred to as conformation. Conformation is just a nice scientific way of saying shape. Okay, to have a function, a protein must have the correct shape. Correct shape, correct function. Correct conformation has the correct level of functionality.